So my task for this session is to set up the floor, like have an appetizer, in the sense that I'm going to present you 3 case studies that were conducted under the umbrella of HEcoPerMed, European Union Consortium collaboration, under the umbrella of HEcoPerMed as well. This was not the only work we did there, but I'm just now highlighting this work, and I'm just highlighting within this work a couple of things. So I'm not covering everything. And the other excuse I have to make that what I'm covering here is not only my work, but of course works of my colleagues within the consortium, especially people from Erasmus University, people from Oxford University, and my colleagues at Syreon. So HEcoPerMed stands for Health Care and Pharmacoeconomics in support of the International Consortium for Personalized Medicine, and it supports research and implementation of personalized medicine in Europe and beyond, especially in the field of health economic evaluations. And we, during this work, produced, first of all, a guidance for the harmonization of improved economic evaluations of personalized medicine, a position paper with the title Lessons Learned and Potential Opportunities Ahead, 6 scientific papers published already, and 7 articles coming soon in a special issue in personalized medicine. So it was a quite productive consortium, I guess, so far. And you can find the website with all the materials. So let's just jump into the 3 case studies. The first one is about enteric fusion testing for the treatment of entrectinib. And excuse me, I'm health economist, so when I'm using the clinical expressions, I hope I'm doing this in the right context, and will still be followable. This is lay economic language. The second case is about a test that identifies through a test called ToxNav that is identifying breast cancer patients at risk of adverse events due to their combined chemotherapy. And the third one is about genetic testing of monogenic diabetes caused by mutations of 3 different types of genes. This is commonly called the MODY. So let's see, and the reason, and I hope that you get now an understanding on the differences that these treatments are coming from, that these personalized treatments are coming from very different fields, and introduce different challenges. And actually, these 3 groups were presenting their base case in different countries. So we were looking for variety. We were looking for challenges, and wanted to see what we worked before on, what theoretical problems, challenges we're going to have when we conduct economic evaluations will occur, and how this will occur in reality. So, and I'm going to be very, very short on the case studies. We'll rather focus on some of the findings and some of the challenges. So the case of NTREC, it's a histology-independent tumor-agnostic therapy, which means that you probably know better than me. It is prescribed based on genetic markers of the tumor, regardless of tissue of origin. And the treatment here, I know there's another treatment as well, is entrectinib, and it's an innovative treatment recently approved by FDA and EMA, and which also means that it's quite expensive, and it is given to patients whose NTREC gene fusion by genetic testing is positive. Very few patients receive or should receive or are eligible for this treatment through genetic testing. This is a key point here. And our question was, is it cost effective to test for NTREC positive patients? And the first challenge that the data, and this is quite common, I think, in personalized care, is not fully there, not as nicely there as in the traditional space of trials. So it was the data the colleagues in Rotterdam had was a single-arm basket trial, and there was no comparator. So they had to handle these issues, finding a right comparator, finding data that can be matched to the other arm of the study, or the original arm of the study, and of course it introduced especially statistical analysis-wise challenges. I'm not sharing you the solutions, but there were, of course, solutions. I'm just bringing in the issue, and I'm just putting some takeaway messages of all the challenges or results we had. This is what you see at the back of at the bottom of the slides. So data problems can occur often when targeting a small subgroup of patients with little histology or information about their potential to improve. The other thing that was that produced some struggles, that there were a number of testing scenarios that had to be analyzed after discussion talks with clinicians. And there were four actual scenarios. One is when you have the new generation sequencing for RNA, but it's quite expensive. Then you have the immunohistochemistry, HIC, test for tumor types that is cheaper, but it's not that specific, not that accurate. And then there could be some combination of these, which from our point of view was important to reduce the cost or to get to the patients with the lowest amount of resources possible. Therefore, these four scenarios, which I'm not sharing all the details about, took place. So takeaway message: patient certification and treatment pathways are not easy to set up when it comes to economic evaluations for personalized medicine, in many cases. Results here. This first case, and you will see the next cases will be more positive, but this was actually not a cost-effective answer, not cost-effective as the answer mostly for the research question we raised at the start. So for none of the countries, so Hungary, UK, Netherlands, the cost of finding the patient and treating the patient compared to the benefits was regarded as not a good value for money. And the reason for this, again, in just a nutshell, that you had to find a few patients only with a quite expensive test. Even the combination which we used here, the HIC test and the NHS test, the combination of them, that was the cheapest strategy, but still not cost effective. So a low prevalence, expensive test, and then expensive treatment coming after this. So these were the main reasons. Of course, we can talk about the methodology and a lot of things as well, but this was the bottom line. What the colleagues did, and it's quite interesting, I think, from the many additional analysis they did, that they just tried to see what happens if the test was for free. And if, of course, it can happen that the manufacturer can give the test together. So there can be scenarios for that. And what if the patient is paying the test for himself? Okay. So there are situations when it can occur, and let's see what happens in terms of from the payer perspective. And what happened was that in that case, for the UK it was almost, but still not cost effective. For the Netherlands it was cost effective, and for Hungary it was not at all. This is what you see on both of the slides here. So reduction of direct stratification costs can be key for the personalization of innovative therapies. That's the message here. The next one and this is the last for this case, and the other cases will be much shorter, I promise, that we also looked at the budgetary impact. And I'm not going into how much money is spent because it's important, but actually the proportion of money spent for this particular treatment, I think, is important. And what we saw here, and you see at the bottom, is that when you look at the percentage of the spendings, the budgetary spending, the incremental spending, what you additionally spend due to this intervention from the healthcare budget, proportion to the healthcare budget, is very, very high compared to the other countries in Hungary, which is the lowest income country from these three actually quite well-developed European countries. So in that particular project and in this particular case, because not all the other cases are such, there was like more than a triple the proportion you had to spend if you were a decision maker in Hungary to spend on this one. Not cost effective and a high budget impact. It is not a nice case. Maybe in the Netherlands, without the test cost, it can be affordable. Okay, so let's see the next case, which was a combination therapy. It can be used in different, so several solid tumor types, and this is causing severe adverse drug reactions due to genetic mutations. And it occurs in 10 to 15%, so quite high percent of patients who poorly metabolize chemotherapy and have an increased risk of severe toxicity. So when you use this test, which I'm not willing again to share all the details, there were tests before that were targeting this particular problem, but this test is much better, and this was developed at Oxford University. So if you use this test, then you help identify multiple metabolizers prior to chemotherapy and allow for the adjustment of the treatment and avoid severe toxicities. Question again, is it cost effective to use ToxNav to test for breast cancer patients before this combination therapy? And now I'm just giving you the answer, yes. And for all countries, there were, for the UK and for Netherlands, it was, the strategy was called dominant, which means that it actually gives additional benefits to the current standard of care, and it's actually cheaper as well. This is the best case scenario for decision makers because you don't even improve the health of the population, but you also save some money. And in Hungary, it was very, very close to be dominant as well, which means that you still need to spend a little bit more, but you achieve a lot. So you have a lot of benefits. Why this happened? Again, just in a very simplified way. The personalization of high prevalence health problem, which is treated with existing, let's call it cheap. It's not true, but it's cheaper than the innovative or the latest innovative care, has good potential to be cost effective. It's not always the case, but this was a nice case for that. Here we also faced some difficulties in terms of the data, but the difference to the previous case was that this test was already used in the area of Oxford, so they managed to collect real-world data, and this real-world data, with some adjustment, was capable to be used for the economic analysis, so it made life much easier that there was an existing evidence on real-world evidence on the effectiveness of the data and also on costs. So in the absence of trial data, effectiveness data can be obtained from real-world data, especially when new genetic tests are developed for long existing treatments with proven benefit. Okay, the last case, the case of maturity onset diabetes of the young, which is a form of monogenic diabetes caused by 13 mutations, and it accounts for at least 1 to 5% of the diabetic population, age of onset typically less than 35 years. And most of these MODY cases are misdiagnosed as type 1 or type 2 diabetes, which means they are taking insulin, which is much more expensive than some alternative treatments, especially sulfonylurea. With proper diagnosis, you don't need insulin treatment. You either get a diet, if you are the GCK MODY mutation, or if you are the other two mutations, then you get the cheaper treatment. Again, the question is it cost-effective to diagnose MODY patients by genetic testing? And here the interesting thing before presenting the result was that we identified at least two ways to get to these patients. Of course, first you identify those who are on insulin and those who are below 35. Then there was a MODY calculator, so risk assessment questionnaire, through which you could set up whose patients have a higher chance, high probability to get this genetic disorder. And then once you manage to narrow the patient population, you then just test those with the expensive genetic testing who are still within this target population. And there is another way, or there is a further way to refine the patient stratification. You can even add a lab test, autoantibody test, that will, through which you lose some of the patients, 1% of the patients, because this test is not always accurate. But then you have to manage much less patients less patients than with the lab test. So what the result, and this is my last slide on the result, and then I just conclude, is that with the lab test, every case was very, very cost effective. So dominant cases again, and very close to being dominant. And without the lab test, so without the narrowing down the population with the lab test, the results were around the threshold of being accepted as cost-effective or not. What the message is, on the one hand, personalization of higher prevalence health problem which is treated with existing cheap care has good potential to be cost-effective. This is the same as for the ToxNav case. I'm just repeating this. And exact method of patient stratification can be a game changer. This is the lab test, what I'm talking about. So conclusion, there are currently methodological challenges, but most of these can be handled by existing methods. The architecture of patient pathways during personalization is not straightforward and has strong influence on the results. Targeting higher prevalence indications and the initiation of changes in existing care has good potential to be cost-effective. The cost-effectiveness and the budgetary impact of personalization varies by countries. And I just would like to thank all my colleagues who took part in this research, and just emphasize that my findings are just based on these 3 case studies. So there might be more, there might be different conclusions for other case studies, but I think these are good to start a discussion later on.